As we are celebrating the Science Week with a theme, reinventing the science education through innovation in the midst of pandemic. As a grade 4 student, we need to make a virus model. I decided to make an influenza virus model. For this, I will be using a styroball, acrylic paint, paintbrush, push pins, clay, pipe cleaner, and glue. After painting, we must let it dry first. After drying, I will put the blue push pins. It represents hemagglutinin. It is an anti-glycoprotein found on the surface of the influenza viruses. It is responsible for binding the virus to the cell that it is being infected. The red push pins represent the enzyme neuraminidase, projecting from the surface of the influenza virus particles, which allows the virus to leave infected cells and spread in the body. Antibodies, which inhibit the enzyme, limit the infection, but antigenic variation of neuraminidase renders it ineffective in a vaccine. After putting all the paints, I will use this green pipe cleaner. I already twisted it. The green pipe cleaner represents ribonucleoprotein, or RNP for short. Complexes of influenza viruses are composed of multiple copies of the viral nucleoprotein NP that can be filamentous suprastructures. RNPs package develop viral genomic RNA segments of different lengths into pleomorphic influenza virions. After I add these pipe cleaners, I add purple clay. The purple clay represents the M2 protein, which forms a homotetramer, has H plus ion channel activity that is sensitive to an anti-influenza virus drug, amantadine, and is active by low pH. When the virus enters cells, the M2 ion channel is activated in the endosomes to acidify inside the virion, facilitating the viral uncoating. This is my influenza virus model. There are 4 types of influenza viruses, A, B, C, and D. Human influenza A and B viruses can cause seasonal epidemics of disease, known as flu season. Almost every winter in the United States and also here in the UAE. I still remember when I was grade 2, that was December, and we were all busy preparing for TPGS Foundation Day. Almost all of us got sick, and it was because of an influenza A virus. Influenza A viruses are only influenza viruses known to cause flu epidemics, i.e. global pandemics of flu disease. A pandemic can occur when a new and different influenza virus emerges and that both infects people and has the ability to spread efficiently among the people. Influenza C virus infections generally cause mild illness and are not thought to cause human epidemics. Influenza D viruses primarily affect cattle and are not known to affect or cause illness to people. An influenza virus binds to a respiratory tract cell. This model illustrates the very beginning stages of an influenza flu infection. Most experts think that influenza viruses spread mainly through small droplets containing influenza viruses. These droplets are expelled into the air when people infected with flu cough, sneeze, or talk. Once in the air, these small infectious droplets can land in the mouths or noses of people who are nearby. This image shows what happens after these influenza viruses enter the human body. The virus attached to cells within the nasal passage and throat, i.e. the respiratory tract. The influenza viruses hemagglutinin HA surface proteins that then bind to sialic acid receptors on the surface of a human respiratory tract cell. The structure of the influenza virus's HA surface proteins is designed to fit the sialic acid receptors of the human cell, like a key to a lock. Once the key enters the lock, the influenza virus is then able to enter and infect the cells. This marks the beginning of a flu infection. I hope you all like my virus model. This is Simon from grade 4A. Thank you for listening. Bye!